Hi, this is my video number 23, the continuation from last video, line integral. So let me begin with this video with the definition. If if C is a piecewise smooth function, smooth curve. This is C is given as union of Ci. So if Ci is a piecewise smooth curve, given by that. So I from 1 to n, right? So then the line integral over f, line integral over f along C is given as, if C is a piecewise smooth curve, then the line integral over f along C is given by that. Okay, where Ci is a smooth curve. This is a smooth curve. C is the combination of those. Then integrate f ds. This is equal to C1 f ds plus C2 f ds plus Cn f ds, which means that we can break the integral, the curve, into a smooth and evaluate each of them separately. Yeah. So for example, if you have C like this, right? This is example. Okay, so we have C1, C2, C3, C4, C5, and so on. Okay, where each of these C's are smooth. Okay, let's see example. So evaluate, integrate C f dot dr, where f is given as yzx and C consists of the line segment C consists of line segment C1 from 2, 0, 0 to 3, 4, 5, and C2 from 3, 4, 5 to 340. Okay, so if we try to describe the C1, C2, this is in 3 dimensions, so we plot in 3 dimensions, x, y, and z. So we have x, y, and z. Right? So we have first point here, 2, 0, 0. Let's say somewhere here. This is 2, 0, 0. 2, 0, 0. Then we have 3, 4, 5. 2 here is 3 here, and 4 somewhere that, and 5. So let's say the point is here, 3, 4, 5, and 3, 4, 0. So this is a point from 2, 0. This is 2, 0, 0. So that, okay, and 3, 4, 5 to 3, 4, 0. So down here, come here. This is 3, 4, 0. Okay, so this is C1, this is C2. Okay, so try to identify C1, try to identify the equation for the C1. So this is just a straight line, just a straight line, so it's not difficult for you. So C1, x is given x. So I use this point. So we have x naught 2 plus v, 3 minus 2 is 1, so t. Y is equal to, y naught is 0, v is 4, so we have 40, and z equal to, z naught is 0, 5t. Right, 5t. Okay, now what about t? I think we may use x from 2 to 3, x from 2 to 3. Okay, you see x from 2 to 3. You can use y, you can use z, but now I'm use I think using z is much easier. Use z from 0 to 5. We have z equal to 5t, z equal to 5t. So when z is 0, t is 0. When z is 5, t is 1. So which means t from 0 to 1. So integration, our integration is from 0 to 1. That's for C1. Okay, so let's do for C1. So what else we need? We need r, dr. What is our dr? dr is, we have dx, dy, dz. So given x, y, z as this, not given, but we obtain x, y, z as that. So you can differentiate this respect to t, that respect to t, that respect to t. That give you dx is equal to dt, dy is equal to 4 dt, and dz is equal to 5 dt. And our f is given as y, z, x. Okay, and in terms of t, just substitute y, z, and x with the parameter t. So we have y is 40, z is 5t, x is 2 plus t. Okay, so f integrate c, f dot dr, this is for C1. So we have integrate C1 t from 0 to 1. Our f is given as that 40, 5t, 2 plus t, dot dt. Our dt is given, dr, our dr is given here is, we have 1, 4, and 5. 1, 4, and 5 dt. Okay, So you can solve this 0 to 1. So we have 40 plus 20t plus 10 plus 5t. So 5 plus 5t plus 10. Correct? Correct. dt. So what you have here, 40, so t2 squared plus 10t squared. Oh, I think we can just simplify that one. 4 plus 24, 29, so we have 29t plus 10 dt. This is 10. So that we have 29t squared over 2 plus 10t, t from 0 to 1. So that give you 29 over 2 plus 10. Okay, then you can simplify this 20, that's 49 over 2. Then for C2, look at your line here. You can see that x, y doesn't change, z also doesn't change, so basically z equal to t. Alright, so you can have this. So x is equal to x is equal to 3, y equal to 4, and z equal to 5t. Right, 5t. So dx give you 0, dy give you 0, dz give you 5 dt. Okay, and your f is y z x, using that component of r that we obtained. So this give you y is 4, z is 5t, x is 3. Right, so integrate c2 f dot dr, that give you integrate c. So I think you from here t z from 5 to 0, so which means you have t from 1 to 0. Use this, you got that t. So t from 1 to 0, your f is 4, 5t, 3 dot, your dr is 0, 0, 5 dt. So that you got 1 to 0, 15 dt, right? So that give you minus 15. So therefore integrate c f dot dr, this is integrate c1 f dot dr plus integrate c2 f dot dr, right? So that give you 49 over 2 minus 15. So whatever value is here, this is 19 over 2. So I hope you can understand that. Can you see this thing? That the first part, and that the second part. Okay. Let's consider another example. Let's consider another example. Let's say we have f equal to x squared y, and c is given as this. We have minus 1 0, minus 1 0, 1 0, 1 1, and minus 1 1, minus 1 1. Okay, so the question is find the work done by force F to move an object from 1 0 to minus 1 0. Okay, from 1 0 to minus 1 0 here. So follow this, that, and that, and that. Okay, try another one. Let's say with f x squared y, same function, but our c is given as like this, from 1 0 minus 1 0, using that. Okay, this line is given as y equal to minus x squared plus 1. This is your c. Okay, and number 3, you may have this. Let's say your f is yz x squared, another one is x minus z, another one is x minus z, x minus z. So your c is given as like this, 1 2 3. Alright, so this is your c. That your c, given as that. I think you can do this. Can I leave this as an exercise to you? Maybe I can try this one. I do number 2. You do number 1. This is number 1. And number 3, I'll do number 2. Number 2, we have y is given by that, c is given by that. Well, our c is given as y equal to minus x squared plus 1. So how are you going to solve this? So we let x equal to t, that will give us y equal to minus t squared plus 1. Okay, so you can choose y equal to t, but you have to write x in terms of y, in terms of t. That give you a little bit difficulty because we have a square root later on. So we take x equal to t. Then we need to differentiate this because we need the r. Why do we do this? Because remember that our r, we have in this term x of t, y of t. Yeah, so we need this. So when we let x is equal to t, so our x is equal to t and our y t becomes like this. Okay, and so we also need dr, So dr is basically we need to differentiate those. Dt, we need to differentiate this negative 2t dt. Then our y, sorry, our f is given as x squared y. All right, using the all these expression that we obtained earlier, so you can have t squared, our y is negative t squared plus 1. Okay, what about the limit of integration? You can choose from here x from 1 to 0, sorry, 1 to minus 1. Okay, since we let x equal to t, since x equal to t and x from 1 to minus 1, so which means t also from 1 to minus 1. Okay, so we do the integration, integrate over c f dot dr. So this is integrate t from 1 to minus 1. Our f is t squared minus t squared plus 1, right? Dot dr, our dr is dt1 negative 2 t dt. Okay, just solve this, integrate 1 to minus 1. This is dot product. Don't make silly mistake here. So we have t squared, that one is so we have minus, so plus 2t cubed minus 2t dt. Okay, so then we can solve, you can solve this easily. So what we have, t cubed over 3 plus t4 over 2 minus t squared, t from 1 to minus 1. Then you can just solve this thing. All right, so with that example, I end up this this video here. Thank you.